Hello everyone and welcome to our YouTube channel. We are working on a series of videos on openmp. In the previous videos, we talked about scheduling for the for construct and we covered static scheduling and dynamic scheduling. In this video, we are going to cover guided scheduling, which is another form of scheduling which is used with the for construct. Okay, so without further ado, let's get right to the program. So the program that you see here, it's pretty much the same as the one in static and dynamic scheduling. The only difference is that now the clause is replaced by guided. So what exactly is guided scheduling? If you ask, then in static scheduling, I'll give you a comparative analysis. In static scheduling, as soon as this line is encountered, each thread is given two iterations. Each thread is allocated two iterations regardless of their speed. So the work is distributed evenly. In dynamic scheduling, this work is distributed based on the speed of the threads. So let's say thread number 48 can get iteration 1 and 2 if it is faster than thread number 0. That does not happen in static scheduling. In guided scheduling, however, what it does is, so I have 16 iterations that need to be performed. So whatever thread is faster, first it will take note of that, whichever thread is faster. And instead of allocating two chunks, this time it will allocate a much larger chunk. So one who comes first gets a larger chunk of work, and the minimum is 2. The 2 is the minimum limit of chunks that will be allocated to any thread. Okay, let's see it in live demo. So currently I'm logged into a HPC Paramrudra, and in that I have loaded certain modules, specifically the Intel 1 API compilers, which is a set of compilers, and as we have talked about in the previous video. I'm in the directory openmp programs where I have stored all the programs. I'll show you the program here also. So it is the same program that I have showed in the PPT. And let's compile this program into G++ and it's openmp underscore guided scheduling. Sorry, I forgot to add the identifier. This is a very specific requirement for this particular system that I'm working on. Now I have a a.out file which I can just print. So as you can see, we got 0, 0, 0, 0. So from 0, 1, 2, 3, and 12, 13, 14, 15. That means that's 6, 6, that's 3, 3, 6, 7, 8. That means 8 chunks. 8 chunks was allocated to thread 0 alone. Why this happened? Because thread 0 was the fastest of all the threads that were present in the race. And since the one who comes faster will be allocated a larger chunk of data, that is why thread 0 got more iterations compared to the other. And if let's see, we can find it here. So thread 1 only got 2 iterations. Why is that? Because 2 is the minimum limit. Any thread needs to take at least 2 chunks of data. Otherwise, it can either work. I'm sorry. If only one iteration is remaining, then there's no problem. Only one iteration will be allocated to that thread. But other than that, other than this extreme scenario, a thread always needs to take at least 2 chunks of data. Why is that? Because we have specified in the program, I need at least 2 chunks of data. And in this also, as you can see, I have limited the number of threads to 4. That is why we are only seeing 0, 3, 2, and 1 here. But if I were to remove this limit, if I were to, let's say, remove this line, I think that would be a better explanation of what I want to. Oh, so by mere coincidence, we have got the same result out once again. Pretty much the same result. but it's a coincidence. Since I have removed the limit on the number of threads, right now, okay, just a second. I think it's a different file. So it may be because of that. Yeah, it was editing on a different file. No problem. Yeah, now you can see it here. So we've got 21, 17, 41, all the different numbers. Why is that? Because these threads were faster than the other threads, simply because of that. And that is all for this session. In the next session, we will be discussing another type of scheduling, runtime scheduling to be specific. Thank you, and please stay for the next video.